In this video, I'm going to introduce the idea of radians. For now, you're going to study this in much more depth in Algebra 2 and in pre-calculus. For now, we're just going to think of it as a different way to measure angles. Just like we have different units of measurement for length. We can measure something in feet, we can measure it in meters. Same idea here. There's something called a radian. I think it's important to note that yes, it does have some relationship to radius. That's sort of the root word in there. So when you learn more about it, you're going to see that it's somehow related to the length of the radius. But right now, we've been talking about the way to measure measure an angle is in degrees. For instance, 220 degrees has units. The units are degrees. We don't always write it. We have this little symbol here for degrees. However, radians are unitless. Yes, we call them a radian, but they actually it's not considered a unit. They do not have units. Again, when you learn about this in pre-calc, that will make a little more sense. For now, we're going to call them radians, but we don't write down when we write an answer like this is 5 radians. We don't write down radians. We just say it's 5. We say usually it has a pi in it, so we'll say it's like 2 pi. What we're going to focus on here in geometry really is the conversion from degrees to radians. If I give you the measure of an angle in degrees, can you tell me what it is in radians? And vice versa. So the way we do this is the first thing, the conversion rate we know that 180 degrees is equal to pi radians. Okay? So we don't, again, I'm writing it in because I'm kind of reading to you, but we don't usually write the word radians. We'll just say pi. And when we talk about it, we do say radians. So just from this, there are some easy ones to calculate. If 180 degrees is pi radians, then how many radians is 360 degrees? Well, it's just double, right? Because 360 is double 180. So it's 360 will be 2 pi radians. How many radians is 90 degrees? Well, again, if 180 degrees is pi, then half of 90 is half of 180, so half of pi will just be pi divided by 2. And for these radians, we are not going to be using 3.14 for pi. We just leave pi in our answer. Radians always kind of, well, they don't always, but radians for us will always have pi in them. We're not converting, just leave it as pi. So if 360 is 2 pi, radians, 180 is pi radians. How many radians is 90? It's pi over 2. How many radians is 0 degrees? It's still just 0 radians. Doesn't have a pi in it because 0 times pi would be 0 anyway. Some harder conversions. So how are we going to convert something like 45 degrees into radians? Well, our conversion ratio is going to be that pi over 180. Since they're equal, that's going to be my conversion ratio. Or sometimes I'll have to do 180 degrees divided by pi. So which one do you choose? Well, I keep in mind that if I want to convert to radians, I want to have radians on the top of my conversion because that's what's going to be left after I do my multiplication. And if I want to convert to degrees, then I'm going to use the one that has degrees on top. So we use this idea that we know pi is equal to 180 to make our fractions. And which one do we use? So in this case, let me use green. I like this better. 45 degrees, I want to convert that into radians. So I'm going to multiply that by a fraction. If I want to convert to radians, that means my degrees need to cancel. So if I have, this is like over 1, don't forget. So in here I have degrees in the numerator. And on this guy, I need to then have degrees in the denominator so that those degrees cancel. So now there's no more degrees left. I'm left with radians. Okay, so that's how I know which one to choose. Like you might be asking, do I choose pi over 180 or 180 over pi? Well, if you have degrees, you need degrees on the bottom. Since I have degrees here that I'm converting, I want to get rid of the degrees, so degrees have to go on the bottom so that those will cancel out. You've done some of this in science when you're canceling units, right? Okay, so now we're going to multiply. So I get 45 times pi, and then I multiply the bottoms, and that's just 180. This would be your angle in radians. Of course, we do want to reduce our fraction, so the pi is going to stay there, but if we look at this fraction, we sort of want to, well, not sort of, we want to reduce that. That's going to reduce to pi, it would be 1 pi over 4. Does 45 go into 184 times? 180 divided by 45. It is 4 times, right? And we don't typically show the 1, so it's going to be pi over 4. So 45 degrees is equal to pi over 4 radians. There's our conversion. Let's try again. 150 degrees. So again, I'm canceling out degrees, so the degrees have to go on the bottom, therefore the pi radians go on top. My degrees cancel. I multiply across the top 150 times pi, then I multiply the bottoms 180 times 1. You really should not have to be putting this over 1 anymore. We know that if we have a fraction times a number that's not a fraction, the number gets multiplied into the numerator, and the denominator doesn't change because it's always going to get multiplied by that 1. So you shouldn't have to show that over 1. Okay? So we get that number, and again, we want to reduce. So that's going to reduce to 5 pi over 6, because 150 over 180 reduces to 5 over 6. So I'm just reducing this number and coming up with that number, and the pi stays with it. Let me get rid of that stuff because it makes it look confusing afterwards. All right, so let's see. Let's do another one. So this one, oh, and we'll write, so 5 pi over 6 is the answer in radians. All right, so that's 150 degrees in radians. Let's do another one, 270 degrees. I'm going to multiply that by pi over 180 degrees. So again, notice every time when I want to convert from degrees to radians, I multiply by the conversion, pi over 180. So I get 270 pi over 180. So now I have to reduce that fraction. I believe it reduces to 3 pi over 2. Let me check my math here. Yep, that is correct. So 3 pi over 2 is my radians. That's 270 degrees in radians. 150 degrees. Again, we're going to multiply by pi over 180 because that's our conversion. The degrees cancel. I get 150 pi over 180. Wait, did we do this one? We did this one already. So that's going to reduce to 5 pi over 6. Sorry. We did that one at number 2. Now let's convert the other way. So here's some of the easy ones. You're supposed to remember or know that pi equals 180. So I don't need to do any multiplying by conversion or whatever. Then the spin-off of that is 2 pi is just double of pi. So double of 180 is 360 degrees. Pi over 2 is just taking it and cutting it in half. So half of 180 degrees is 90 degrees. So those you should sort of just know. Those three kind of come up quite often, and you're gonna want to just know those without having to multiply by anything. What if we get a harder one like this? So now your pi is in your numerator, so we're going to multiply by 180 over pi. Because I want to cancel out the pi. When I get degrees, it shouldn't have a pi in it. So since pi is in the numerator, I do the 180 over pi. Notice that's the reciprocal. I've flipped it from before. It was pi over 180. That's going from degrees to radians. Now I'm going from radians to degrees. So the first thing is the pi's cancel. So then I multiply the fractions, and I have 180 times 5 gives me 900 on the top, and then 6 times 1 is just 6. So I have 900 over 6. If I do that division, I get 150 degrees. That is 5 pi over 6, and we did that one twice, I believe, right? It was just I gave you 5 pi over 6 and so tried to see if you can come up with 150. That's what we did here in number 4. We went the other way. All right, how about pi over 3? So again, we want to cancel the pi because we want to get rid of the radians. So the pi has to go on the bottom, and we'll have degrees left on top. So pi over pi cancels. 180 times 1 is 180. On the bottom, I got 3 times 1 is 3. 180 divided by 3 gives me 60 degrees. So pi over 3 is equal to 60 degrees. Remember, pi over 3 is in radians. And now I've converted my angle measure to degrees. 5 pi over 4, so I want to get rid of that pi because I'm trying to come up with degrees. So the pi's cancel. I multiply across the top. 180 times 5 is 900. 4 times 1 is 4. 900 divided by 4 gives me 225 degrees. That's what 5 pi over 4 radians is. And let's do one more just to be sure here. I have pi in the denominator because I want to cancel my pi's, and I have 180 degrees up top. I cross off my pi's. I multiply the 180 times 3. You get 540. I multiply the 2 times the 1. I get 2. I reduce, and I'm going to get 270 degrees. Okay, so that's how you convert one way or the other. Keep in mind that we're multiplying by this fraction, and it's either 180 over pi or pi over 180, and that's because our conversion fraction can be that because we know that 180 degrees is equal to pi in the first place. That's why we can use that fraction. Thank you.